Welcome, my friends! In this video, I will be introducing the polar coordinate system. In a rectangular coordinate system, which you're most likely familiar with, we plot points according to their xy coordinates. On the graph, we indicate the point based on how many units we should move to the left or right, indicated by the x coordinate, and how many units we should move up or down according to the y coordinate. In polar coordinates, on the other hand, we plot coordinate points according to r and theta. So another way you could indicate the exact same point is not by the x and y coordinates, but by r and theta. Theta means which angle, measured counterclockwise from the positive x-axis, should you go in order to reach that point. R says how many units along the angle theta should we travel in order to reach the point. So you can imagine from the origin, which is actually called the pole in polar coordinates, we would have to go out some angle from the positive x-axis in order to reach this point, and we would have to go out so many units, which we call r. As you can imagine, r comes from the radius of a circle. As you can kind of imagine this point being somewhere on a circle. So the radius would be the distance from the center all the way to that point. So summarizing what I've been talking about, theta is going to designate the counterclockwise angle from the positive x-axis that must be traveled in order to reach the point. R is going to designate the distance that must be traveled in the theta direction to reach that point. Now, although not strictly necessary, polar coordinates are oftentimes graphed on a template that looks something like this. You have a bunch of different circles which help you gauge the radius, r. So for example, each circle here is going to represent a different size radius. So the first circle has a radius of 1, the second has a radius of 2, 3, 4, 5, 6, 7. And then we have a number of lines which indicate our angles. Pi over 6, pi over 4, pi over 3, etc. All the common angles on one revolution of the circle. Let's practice plotting some points. Say that we are asked to plot the points with polar coordinates 2, pi over 6. Remember that polar coordinates are expressed r, theta. I typically like to think of the angle theta first. So pi over 6 would be in this direction. So what this is saying is go 2 units out in the pi over 6 direction. So here's the pi over 6 direction. We need to go out 2 units. So that would be 1, 2, and this would be our point right here. So the point 2, pi over 6 is this point right here. Let's try another one. Say we are asked to plot the point with polar coordinates 6, 4 pi over 3. So we must go out 6 units in the 4 pi over 3 direction. So where is 4 pi over 3? Well, 4 pi over 3 would be down here in the third quadrant. So we must go out 6 units. So that's going to be 6 circles. 1, 2, 3, 4, 5, 6. So this would be our point right here. 6, 4 pi over 3. Let's try a few more. We are asked to plot the point with polar coordinates 0, pi. This tells us to go out 0 units in the pi direction. Well, here is the pi direction, but if we're going out 0 units, we are going to be at the origin, which I mentioned before is typically called the pole in polar coordinates. So the point 0, pi is just going to be the pole, which is the same point as 0, 0 in rectangular coordinates. How about this one? We are asked to plot the point with polar coordinates 3, negative 3 pi over 4. So this means go out 3 units in the negative 3 pi over 4 direction. Hopefully you are familiar by now that negative angles mean you are measuring in the clockwise direction rather than the counterclockwise direction. So we must find negative 3 pi over 4. So where is negative 3 pi over 4? Well, this would be negative pi over 4. This would be negative 2 pi over 4. So that means that 5 pi over 4 must be coterminal with negative 3 pi over 4. So we must go out 3 units in that direction. So we have 1, 2, 3. We would be at this point right here. This is the point 3, negative 3 pi over 4 if we are plotting in polar coordinates. Okay, let's try one more. We are asked to plot the point with polar coordinates negative 4, 2 pi over 3. Now this is a little bit different because we actually have a negative value for our radius. So what does that mean? Well, let's first just think about our angle. Our angle is 2 pi over 3. So where is 2 pi over 3? Well, that would be right here. But the negative 4 means don't go in the 2 pi over 3 direction, go in the opposite direction. So we are not going towards the angle of 2 pi over 3, we're actually going in the opposite direction, which would be sort of like going in the direction of 5 pi over 3. So we're going to go 4 units out in this direction. 1, 2, 3, 4, and we would have this point right here. So a negative radius means just go in the opposite direction. And I guess there is one more, so let's do this last one here. So let's plot the point with polar coordinates -7, -11 pi over 6. Okay, well, let's first start out by finding where -11 pi over 6 is. -12 pi over 6 would be one complete rotation of the circle, all the way around in the clockwise direction. So -11 pi over 6 must be pi over 6 less than one full rotation. So this would be -12 pi over 6 all the way around. We must be 1 pi over 6 less than that, which would be coterminal with pi over 6. But we don't go in the pi over 6 direction because we have a negative radius. So we're going to go in the opposite direction, towards 7 pi over 6. So we're going to be 7 units out in the 7 pi over 6 direction, which would be at the edge of our circle, which is going to be right here. So this is the point -7, -11 pi over 6. Many times you might want to convert from rectangular to polar coordinates or vice versa. We know that on the graph, we can represent the rectangular coordinates as x, y. That means you must go out some number of units to the left or right according to the x-coordinate, and some number of units either up or down according to the y-coordinate. The polar coordinates allow us to designate the exact same point, but in a slightly different way. This tells us to go out r units in the theta direction. So either way, whether or not you are using rectangular or polar coordinates, you are still designating the exact same point. But perhaps we would like to convert from rectangular to polar coordinates or vice versa. Let's first start by talking about how to convert between rectangular to polar coordinates. Well, if you look at our picture here, we've basically created a right triangle. We have a triangle with a base of x, a height of y, and a hypotenuse of r. We know based on the Pythagorean theorem that x squared plus y squared will equal r squared. If we'd like to solve for r directly, we can take the square root of both sides. We will get that r is equal to the square root of x squared plus y squared. Now technically this should be plus or minus the square root of x squared plus y squared, but generally we just write the positive square root. We could represent r as a negative value, but generally we would prefer it to be positive, so that is the way I'm writing the formula. So if you would like to find r, and you already have the rectangular coordinates x, y, all you need to do is take the square root of the x-coordinate squared plus the y-coordinate squared. Now if we would like to find theta, we have to somehow relate theta to x and y. Well, we know that tangent of theta is the opposite side divided by the adjacent side. So tangent of theta is just equal to y over x. If we'd like to solve for theta, then that means we would have to take the inverse tangent of both sides. So that means that theta is equal to inverse tangent of y over x. Now, there's a slight problem with this formula in that this only works if the angle theta is in the first or the fourth quadrant. Inverse tangent has a range such that it will always give you an angle either in the first or fourth quadrant. But if your rectangular coordinates put you in either the second or third quadrant, then this will not work. It turns out you can find the correct angle by just adding 180 degrees if you are in either quadrant 2 or quadrant 3. The reason is tangent has the same sign, positive or negative, in the quadrants that are 180 degrees away from each other. So you will always get an equivalent answer if you just add 180 degrees, or pi if you're talking about radians. Okay, so let's talk about going the other way, if you already have polar coordinates and would like to convert to rectangular. We would have to somehow relate x to r and theta, and y to r and theta. The way we can do that is with cosine and sine. Let's start with cosine. Cosine of the angle theta is the adjacent side divided by the hypotenuse, or x over r. If we multiply both sides by r, we will get that x is equal to r times cosine of theta. So if you already have the polar coordinates r, theta, you can find x by taking r and multiplying by cosine of theta. Sine of theta is equal to y over r, or opposite over hypotenuse. If we multiply both sides by r, we will get that y is equal to r times sine of theta. These are the four formulas that you will be using in order to convert from rectangular to polar, or from polar to rectangular. Let's try some problems. We are asked to convert the point with rectangular coordinates 1, square root 3 to polar coordinates. We would like to express the angle theta in degrees. So although not strictly necessary, it may be useful to sometimes plot the initial point onto the graph. The point 1, square root 3 in rectangular coordinates means go out 1 unit to the right and then go up square root 3 units. That would put us somewhere over here in the first quadrant. Polar coordinates, on the other hand, are expressed as r, theta. So we want to know what angle theta would we have to travel counterclockwise from the positive x-axis in order to be in the direction of this point. And then also, how many units out in that direction should we go, which will be r. We can figure this out by using the formulas from earlier. We know that r is equal to the square root of x squared plus y squared. The x-coordinate is 1 and the y-coordinate is square root 3. So we have the square root of 1 squared plus the square root of 3 squared. This simplifies to the square root of 1 plus 3, which is the square root of 4, or just 2. That means we must travel 2 units out to get to this point at some angle theta. But what is that angle? Well, we can find that by taking the inverse tangent of y over x. This becomes the inverse tangent of our y-coordinate of square root 3 divided by 1. Now you could type this into your calculator, but if you are familiar with your unit circle in terms of tangent, you don't really need it. This asks us tangent of what is equal to the square root of 3. And hopefully you know that in the first quadrant, the angle where tangent is equal to the square root of 3 is just pi over 3. But of course they've asked us to express the angle theta in degrees. So instead of using pi over 3, we could express this as 60 degrees. The polar coordinates r, theta are 2, 60 degrees. This means in order to reach this point, we could either go out 1 unit to the right and square root 3 units up, or we could go out 2 units in the 60-degree direction. Let's try another problem. We are asked to convert the point with rectangular coordinates -2, 2 to polar coordinates. Again, we are asked to express theta in degrees. Let's plot the point onto the graph. The point is -2, 2, which puts us in the second quadrant. Polar coordinates are expressed as r, theta. So we need to know what angle theta do we need to travel along in order to reach this point, and how many units in that direction should we go. We can find the value r by taking the square root of x squared plus y squared. We have the square root of -2 squared plus +2 squared. This becomes the square root of 4 plus 4. 4 plus 4 is 8, so we have r is equal to the square root of 8. We must travel out the square root of 8 units in some direction to reach the point. To figure out the angle that we must travel the square root of 8 units out in, we can use the inverse tangent of y over x. This will become the inverse tangent of 2 over -2. This becomes the inverse tangent of -1 if you simplify. Now if you type this one into your calculator, you're actually going to get -45 degrees, which is, of course, not correct. -45 degrees is somewhere in the fourth quadrant. The reason you get -45 degrees is because inverse tangent always gives you an angle either in the first quadrant or the fourth quadrant. Our point is in the second quadrant, so inverse tangent will not give us the correct answer. We'll have to adjust by adding 180 degrees. 45 degrees plus 180 degrees would just be 135 degrees. So we must travel the square root of 8 units in the 135 degree direction in order to reach this point. -2, 2 in rectangular coordinates is the same thing as the square root of 8, 135 degrees in polar coordinates. Let's try another problem. We are asked to convert the point with rectangular coordinates 0, -1 to polar coordinates. Here we have our xy coordinate system, and we have the point 0, -1. Now, if you're thinking critically about this one, you don't really need to use the formulas in order to figure out this point. This point is along the y-axis, which means that the angle theta must be 270 degrees. So we must travel out 1 unit in the 270 degree direction. So the polar coordinates are going to be 1, 270 degrees. We can also show this using the formulas. R is equal to the square root of x squared plus y squared. We get r is equal to the square root of 0 squared, the x-coordinate, plus -1 squared, the y-coordinate. This leaves us with r is equal to the square root of 1, or just 1. We must travel 1 unit in this direction in order to reach the point. Now what direction is that? Well, we can take the inverse tangent of y over x. If we plug y and x into our formula, we get a little bit of a problem. -1 over 0 is undefined, since we cannot divide by 0 in mathematics. So this is not going to give us an answer. So again, you have to think a little bit critically about what this angle is. This angle is just 270 degrees, so theta is 270 degrees. The polar coordinates r, theta are 1, 270 degrees. Alright, let's try another problem. We are asked to convert the point with rectangular coordinates -4, -1 to polar coordinates. Express theta in degrees and round your answers to the nearest hundredth. so the point -4, -1 puts us somewhere in the third quadrant. If we want to solve for r, we can take the square root of x squared plus y squared. This will be the square root of -4 squared plus -1 squared. This is the square root of 16 plus 1, or the square root of 17. We must travel the square root of 17 units in some direction to reach our point. What direction must we travel? Well, let's find theta by taking the inverse tangent of y over x. We have the inverse tangent of -1 divided by -4. This becomes the inverse tangent of 1 over 4. If we type this into our calculator, we will get 14.04 degrees. But of course, 14.04 degrees would be somewhere in the first quadrant. Since inverse tangent will always give us an angle in either quadrant 1 or quadrant 4, if our actual point is in either quadrant 2 or quadrant 3, we must add 180 degrees. Adding 180 degrees will give us 194.04 degrees. The polar coordinates r, theta are the square root of 17, 194.04 degrees. Let's try going the other way around. Let's say we already have the polar coordinates 3, pi over 6, and we want to convert to rectangular coordinates. So on the graph, you could imagine us going in the pi over 6 direction 3 units. That would put us approximately over here at 3, pi over 6. Rectangular coordinates are expressed as x, y. We can find the x-coordinate by taking r and multiplying by the cosine of theta. That means x is equal to 3 times the cosine of pi over 6. Cosine of pi over 6 is the square root of 3 over 2, so we have 3 times square root 3 over 2. So our x-coordinate is 3 square root 3 over 2. As for the y-coordinate, we can find that by taking r and multiplying by sine of theta. We have 3 times the sine of pi over 6. Sine of pi over 6 is just 1/2, so we have 3 times 1/2, or 3/2. The rectangular coordinates x, y are 3 square root 3 over 2, 3/2. To reach this point, we can either go out 3 units in the pi over 6 direction, or we can go 3 square root 3 over 2 units to the right, and 3/2 units up in order to reach the exact same point. Okay, let's try one final problem. We are asked to convert the point with polar coordinates -4, -7 pi over 6 to rectangular coordinates. So let's first locate the angle -7 pi over 6. -7 pi over 6 means we are going in the clockwise direction 7 pi over 6 units. -6 pi over 6 would be the same thing as -pi, so we must be 1 pi over 6 above that. But notice we have a negative radius, so that means we are going to be going in the opposite direction. So we must be going in this direction, so the point will be somewhere over here, -4, -7 pi over 6. Rectangular coordinates are expressed as x, y, and the x-coordinate can be found by taking r and multiplying by cosine of theta. We have -4 times the cosine of -7 pi over 6. The reference angle for -7 pi over 6 is pi over 6. Cosine of pi over 6 is the square root of 3 over 2, but since we are in quadrant 2, the answer will be negative square root 3 over 2. 4 over 2 is just 2, and the negatives cancel, so we have 2 times the square root of 3. The x-coordinate is 2 square root 3. As for the y-coordinate, we must take r and multiply by the sine of theta. R is -4, and theta is equal to -7 pi over 6. -7 pi over 6, again, has a reference angle of pi over 6. Sine of pi over 6 is just 1/2, and -7 pi over 6 is in quadrant 2, where sine is positive. So we have -4 times positive 1/2. -4 over 2 is just -2, so the y-coordinate is -2. The rectangular coordinates x, y are 2 square root 3, -2. We can either go out 2 square root 3 units to the right and 2 units down in order to reach the point, or we can go -4 units in the -7 pi over 6 direction in order to reach this point. Alright my friends, that finishes this video introducing polar coordinates.